Have you ever felt like you're just drowning in a sea of slightly different function names for what is basically the same task? Well, today we're going to break down a really powerful feature in Java called overloading. It's going to help you tame all that complexity and write code that's so much cleaner and honestly just more intuitive.
So, here's the game plan. First up, we're going to talk about what this overloading superpower really is and why it's so incredibly useful. Then, we'll dive in and see it in action, both with regular functions or methods and with constructors for our objects. And of course, to make sure this all sticks, we'll wrap up with a handy little cheat sheet. Let's do this. All right, let's get right to the big question. It might sound a little weird at first, right? Why would you give a bunch of different functions the exact same name? But trust me, it's actually a genius way to make your code less confusing, not more. Let's see how that works. Okay, just imagine for a second you're writing code to add numbers. You'd need one for 2 integers, so add 2 ints. Then one for 3, add 3 ints. Oh, but what about floating point numbers? Okay, add 2 doubles. You see where this is going? It gets messy fast. It's not just cluttered, it's a total nightmare to remember which name to use and when. But what if there was a much better way? And there is. This is exactly where overloading comes in. It's a simple but really powerful idea. Just use one single intuitive name, like add, for a whole family of similar operations. It's all about bringing a little bit of order to all that chaos. You know, it's a lot like the word play in English. You can play a guitar, play a video game, or play a role in a show. You don't get confused because the context tells you what play means. Well, Java's compiler is just that smart. It looks at the data you give a method and figures out which version you actually meant to use. It's kind of like having a built-in grammar checker right in your code. Okay, so we get the why. Now, let's get into the how. This is where the rubber meets the road with our first big example, method overloading. We're about to see this theory come to life in some actual code. So check out this greeter class. We've got 3 methods here, and notice they are all named greet. The secret sauce is in the parameters. One takes nothing at all, another one takes a string, and the third one takes a string and a number. This right here is method overloading in its purest form. So what happens when we call g.greet with empty parentheses? Well, Java knows exactly what to do. It looks at all the greet methods, finds the one that takes 0 parameters, and says, yep, that's the perfect match. It's really that easy. All right, now let's give it a little more to work with. This time, we call g.greetMina. We're passing in a piece of text, a string. So Java scans the list of greet methods again, and boom, it finds the one that's built to accept a single string. Perfect fit. And for the final piece of the puzzle, let's pass in both a string and an integer. And you guessed it, Java is smart enough to route this call to the most specific version available. This is the real magic of overloading, right? You get one simple name, but it has multiple behaviors, and you don't have to juggle a dozen different function names in your head. So, what's the big takeaway here? It's that the magic is all in the parameter list. That combination of the method's name plus the types of its parameters, that creates a unique signature. The compiler uses that signature to do all the heavy lifting. You just give it the data, and the compiler figures out the rest for you. Okay, we've pretty much nailed method overloading, but the fun does not stop there. We can apply this exact same idea to constructors. You know, those special methods that actually build and bring our objects to life. Constructor overloading is really all about giving you options. It lets you create an object in a bunch of different, convenient ways. Maybe you just want a quick, no-fuss default version. Or maybe you need a really customized version with specific starting values. Overloading lets you have it all, using the same class name. Just look at this example. Call new rectangle with nothing, and you get a standard 1x1 square. Give it a single number, like new rectangle 5, and you get a 5x5 square. Give it 2 numbers, new rectangle 2, 7, and you get that custom 2x7 rectangle. The code just makes sense when you read it. It's clean, it's clear, and it's all because of constructor overloading. So how does this work behind the scenes? Well, the secret is that little keyword, this. It's a special command that lets one constructor call another constructor in the same class. This is an awesome technique for cutting down on copy-pasted code and keeping all your main setup logic in one central, easy-to-manage place. Let's just trace the call for a second. When you say new rectangle with no arguments, the the constructor with no arguments gets called, but it doesn't really do any work itself. Instead, it immediately passes the buck to the main constructor by calling this with 1 and 1. That's such a smart way to funnel everything through one core piece of logic, which makes your code so much more reliable.
Whew, we've covered a lot. So let's wrap this all up with a quick cheat sheet to nail down the key rules and benefits of overloading. This is the stuff you'll definitely want to remember.
Okay, here are the golden rules. First and foremost, it is all about the parameters. You have to change the number of parameters, the type of parameters, or their order. And a super important point, you cannot overload a method just by changing its return type. The whole point of this is to make your code cleaner and more readable by using one consistent name. And it's perfect for providing convenient shortcuts and default behaviors.
So I'll leave you with a final thought. Now that you've got this tool in your toolbox, where are you going to use it first? Think about the code you're writing right now. Where can you use overloading to make things simpler and clearer? Because this isn't just some abstract theory. It's a practical tool you can use today to make your life as a programmer a whole lot easier. So go on, give it a shot.